Hello students. So today we are going to be talking about all the transformations. So I'm going to go through, do a couple examples of each type, and we'll go from there. So if you need more examples or whatever, you can always refer to previous videos in this unit that go in more depth than all the different transformations. So this first transformation is translation. This is where you slide the shape along the graph, right? And it'll describe what it wants you to do. So like it might want to go one right, one down, or one left, 10 up, or whatever. It's going to tell you to do something. And basically all you do is you just do what it says. So you just look at each point on your shape and do exactly what it says. So 1 unit right, 1 unit down. So you just go 1 right, 1 down, and there's your new K. And again, we put a little apostrophe next to it, and we always label. The apostrophe means prime, right? And it just means that shape has been transformed. And I'm zooming in here so you guys can better see what I'm doing. So there's the K, and there's the little apostrophe symbol next to it. And then J, 1 right, 1 down, there's the new J prime. So J prime. Okay. And then, let's see, do we need this light on? No, we don't. It just causes a glare. Okay. And then the next one, L, we go 1 right, 1 down. There's L prime. And then M, 1 right, 1 down. There's M prime. Okay. And that is my new translated shape that has been moved 1 to the right and 1 down. Okay, now that's not all I have to do. I have to write down the ordered pair of the new points. So again, I just kind of look at where the point is now. These are both on the y-axis, so J is at 0 and 2, and K is at 0, 3. So my new J prime is 0, 2, and K is 0, 3. Okay, L prime is clear over here at 5 and 2. So L is 5, 2. And M is over here at 3 and -2. So again, if you're not sure how I'm getting these numbers, I'm just counting how far over I go. That's 3 on the x-axis. And I'm going down 2. That's -2 on the y-axis, right? So 3, -2 would be the point. And that's all you're doing. Okay? All right, let's try another one. So this time we've got the written rule here, right? So this is the more mathy way of saying left, right, up, down, or whatever. So again, if you take away numbers from your x value, that's going to move things to the left because that's the negative direction, right? If you were to add to the x value, it would move things to the right. So this is literally just saying left 4 spots. Okay? So I'll just write that on here. Left 4 is all x minus 4 means. Okay? And likewise, same idea with the y. The positive direction of the y is up, negative direction is down. So if it's saying add, you're going to go up that number. If it's saying subtract, you're going to go down that number. This is +2, so it's literally just saying up 2. So it's basically what we saw in the first problem, just in a different way. This is just saying go left 4 and up 2. So from each of these points, we'd go left 4 spots and up 2 to get our new spot. So that's R prime right there. Okay? Q would go 1, 2, 3, 4, and then up 2. There's Q prime. Okay, S, 1, 2, 3, 4, up 2, there's S prime. Okay, and then T, I don't know if you can see it very well. T, go 1, 2, 3, 4, up 2, there's T prime. Right there. So my new shape slid to the left 4 spots and up 2 is right there. Now again, we need the ordered pairs. So Q we moved over and up and it became -4, 0. R became -4, 5. S became -1, 4. And T became 0, -1. And again, I got those order pairs just by looking at the points on the coordinate plane. -4, 0, -4, 5, -1, 4, and 0, -1. Okay? All right, so that's translations. Let's talk about reflections. This might be a little bit of a longer video. Just FYI. Again, if you need to, fast forward, rewind to whatever part you need. So, reflections is where we have a mirror line. So, y equals is the horizontal line, right? So, y equals 3 is going to be this line right here. So, that's my mirror line. That's the line I'm reflecting across. So, again, when we reflect, we just count to the line. And then we count that many spots past the line to get a reflection. Because again, if you think about it, if you look at a mirror and you're 2 spots away from the mirror, right? Your reflection is going to look like it's 2 spots away from the mirror. But if you take a step forward, your reflection is going to take a step forward 1 spot, right? If you put your hand on the mirror, it's going to look like your reflection is putting its hand on the mirror. That's kind of how mirrors work, right? Essentially, all that happens when you reflect across lines, it just kind of flips the image over the line. So H is 2 spots away, so its new shape is going to be 2 spots past the line, right where G is. So G is also the same as H prime. And G is 2 spots away, so it's going to be right where H is. So there's the new G prime, same as H. F is 1 spot away, so there's the new F prime 1 spot past it. Okay, and there is your reflected shape. Pretty much the same shape, just reflected across that line. So F went down to, let's see, it's -3, 2. And G is 0, 1. 0, 1, and H is 0, 5. H prime. Okay, so that's all we did. Let's try another one. Let's look at reflection across the y-axis. So on this one, we're reflecting across the y-axis. Now, this is the y-axis, right? W is already on it, so it's like already on the mirror, right? So we don't do anything with it. W and W prime are the same. But X is 1, 2, 3 spots away, so its reflect point would be 1, 2, 3 spots past our mirror line. So there's X prime. And Y is 1, 2, 3, 4 spots away, so 1, 2, 3, 4 spots past it would be Y prime. And there is our reflected shape. Just flips across the y-axis, right? Notice it's the same triangle or whatever, it's just flipped. So y became, instead of -4, -5, it's now +4, -5. X became +3, -1. And W was originally 0, -2. Oh, and I put that in the wrong spot. You guys at home are like, what are you doing, Anderson? Well, I'm putting things in the wrong spot, obviously. X was 3, -1. And W is 0, -2. And that's it. All you're doing for reflections. Okay. Now let's talk about rotations. And I'm going to zoom out here a little bit to do these. Zoom, 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 zoom. Okay, that's probably good. All right, so 90 degrees counterclockwise. First of all, if we think of a clock, clocks go, like here's a clock, right? The clocks go this direction, right? They go to the right. So if you were to say, so this is clockwise. If you were to go the other direction, like to the left, that'd be counterclockwise, right? So that's an important one to be able to understand for what I'm about to show you. So this one wants me to do a rotation 90 degrees counterclockwise about the origin. So don't worry too much about the origin part because we're going to do all these about the origin. But I'm going to show you a trick for these. And I'm guessing it's a trick you saw in the last video. But counterclockwise would be turning to the left. And if I turn my book to the left 90 degrees, which is just on its side, right? If I turn it to the left 90 degrees, that is that shape rotated 90 degrees counterclockwise, right? If I think of this as the y-axis now, and this is the x-axis, this is my transformed shape. This is what it's going to look like, okay? So this is what it looks like originally, right? Or like this is why it's in this bottom left quadrant sneaking up into the top left quadrant. But when you rotate it 90 degrees counterclockwise, it's now in the bottom right quadrant sneaking into the bottom left quadrant. It just moved one quadrant counterclockwise, right? That's all it did. So just to make it easy on ourselves, we don't really have to do too much. We just look at, if we treat this like the y and this is the x, these are the points. These are the ordered pairs that it needs to be. And ultimately, that's all I'm trying to find here, right? So r, after you transform it, would be negative 2, 1. So negative 2, 1. Okay? Q would be 1, negative 1. So 1, negative 1. Okay, and S is negative 1, negative 4. So negative 1, negative 4. And T is 4, negative 5. 4, negative 5. And that's your transformed points, rotated 90 degrees counterclockwise. Okay? So, if I were to then graph these points, negative 2, 1, that's R prime. S is negative 1, negative 4, there's S prime. Q was 1, negative 1, there's Q prime. And T is 4, negative 5. And there's T prime. So there's my transformed shape right there. Okay? And again, you'll notice all these letters just moved one quadrant to the left. 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 That's all they did. I know that's technically right, but if you're going left on the clock is what I'm talking about. Okay. Let's try another one. So this one, we want to rotate 180 degrees. It doesn't really matter if we go counterclockwise or clockwise here, because 180 degrees is just halfway or upside down. So if we now notice, again, these are in the upper left quadrant and bottom left quadrant a little bit there, right? So if I were to rotate it 180 degrees, it should move 2 quadrants away, right? So if I move this upside down, that, right, not that one, this one. That is my new rotated shape there, right? So, again, I can just write down these points and do it. So this is now, again, in the bottom right quadrant. So it's moved a couple of quadrants here, right? So L prime is going to be at 2 and negative 3. So 2, negative 3, K is at 4, 0, and M is at 2, 1. So 2, negative 3, 2, 1, 4, 0. So L was 2, negative 3, M was at 2, 1, and K was at 4, 0. And there is my new points, right? So if I go ahead and graph those points, it should be that same triangle, just kind of facing the other direction, going down right here, right? So it is 4, 0 was K prime. And then L prime was 2, negative 3, L prime. And then M was 2, 1, M prime. Just like that. And there is, again, the same triangle. Maybe if I could draw straight anyway. Same triangle. Just moved 2 quadrants. Just rotated that way, right? And again, you can do that just by moving your book. Not too tough, right? And then last one, do we have dilations? Oh, we don't have dilations on here. So yeah, I guess I'm just going to talk about the, oh no, I do have dilations. Never mind. Dilation, last one. So dilations is just multiplying your number, your ordered pairs by whatever number it gives you. So dilation. So what I'm going to do first here is I'm just going to write the original ordered pairs just kind of off to the left here, just so I know what I'm multiplying by. So C is negative 2, 2. So no, not on there because that's not C prime. Negative 2, 2. B is negative 1, negative 3, negative 1, negative 3. And then D is 0, 4. And E is 2, negative 1, 2, negative 1. So all I do now is I just multiply all these numbers. I'll zoom in here a little bit, I guess. I just multiply these numbers by 0.5. So in your calculator if you want, although I'm going to do those in my head because I can, but you would just do like negative 1 times 0.5 to get negative 0.5, right? So when you multiply these two numbers by 0.5, you'd get negative 0.5 and you'd get negative 1.5 for B prime. And then for C, negative 0.5 times negative 2 is just negative 1, and 0.5 times 2 is 1. So there's C prime. 0 times 0.5 is still 0, and then 4 times 0.5 is 2. So there's D prime. And then E prime would become 1 and negative 0.5. Now, anytime you multiply or dilate by a number that is less than 1, it's going to shrink your shape. Anytime it's more than 0.1, it's going to grow your shape. Now, this was less than 1, right? So it's going to shrink our shape. So when I graph it, you'll see B is now negative 0.5 and negative 1.5, which is right there. So B prime. C is now negative 1 and 1. So there's C prime. D is now 0, 2. So there's D prime. And E is now 1 and negative 0.5. So there's E prime. And you'll see it is just a smaller version of the same shape. Okay. It's all dilation is. It just grows or shrinks that original shape. So this time we're going to dilate by 2.5. So this is going to grow the shape. But I'm going to just, again, write down the original ordered pairs first. So K is at 2, negative 1. So 2, negative 1. L is at 0, 2. And M is at 2, 2. 2, 2. Just like the ballerinas, right? Now we're going to multiply those by 2.5. So 2 times 2.5 is just 5. I'm not sure why I put that in the calculator, but it did. All right, so 5 and negative 2.5 would be the new K. And then it would be 0 still and 5. And then it would be 5, 5. For M. And that's our new ordered pairs. So again, we would just put that, or to graph that, we would just go, that should be a negative 2 and a negative 5. Sorry, I did not write down the right numbers for K. Those are both negative x's. All right, so negative 5 and negative 2.5 would be right there. So there's the new K. K prime. And then L is 0, 5, so it went up here. There's L prime. And M is 5, 5, so there's M prime. So there is our new triangle. Right there. Okay. And just notice all those points just kind of grew and went out there. There's nothing growing this direction, which is why this line pretty much matches with this line. Right? Okay. That's all the transformations. If you have any comments, concerns, or questions, just let us know. We're here to help, and I will see you out there.